in just about, we're gonna get rolling in just about a minute or so. We'll give people a chance to join. Welcome, everybody. Do you want to give me a thumbs up in chat when we should get started? All right, I have gotten the thumbs up. Welcome everybody to the Log4Shell webinar, what we finally refer to as Stranger Danger here. Myself, my name is Micah Silverman. I run our acceleration program for the Stranger Danger workshop program. If you're not familiar with it, it's workshops like these where we do live hacks and hopefully leave you with knowing more than you knew coming in. And on joining me today, we have Simon Maple, our field CTO, and Eric Smalling, senior developer advocate here at Snyk as well. I'll give them just a moment to introduce themselves. Why don't you go ahead, guys?
Hey everyone, good to be here. Nice to be able to present this to you today. My name's Simon Maple, as mentioned, field CTO. I've been in engineering teams for 20 odd years. I'm a Java champion and been a Java developer for well over 20 years. So happy to be here today.
And I am Eric Smalling,
Excellent.
senior developer advocate on the cloud native and container side of the house. I also am a former Java developer, recovering from that. About 30 years of software development behind me. Specializing in CI/CD and all the cloud native stuff.
All right, well, welcome. I forgot to mention I too am a Java developer, and probably most people joining are either Java developers or Java developer adjacent, so welcome. We're going to cover a lot of ground here today, and hopefully you will dig it. We're going to start with what is Log4Shell. We're going to kind of look at its anatomy. Simon's going to show you some great Log4Shell in action and how you remediate it. Eric's going to jump in with a bunch of great container examples, and we'll wrap up with a deep dive into the code so you can see what is actually triggering this vulnerability, and we'll leave plenty of time for Q&A. So I'm going to hand this off to Simon to talk about what the heck is Log4Shell.
Yeah, so I'm going to just be brief here in terms of the TLDR, really. So if you took one thing away from this session, of course, we all know that Log4j is a highly prevalent vulnerability. It's critical, actually composes of two separate remote code execution vulnerabilities. There is an additional denial of service, although that's not part of the Log4j. It's just another vulnerability on Log4j because it doesn't provide you with the ability to get a shell to do the remote code execution. It's quite easily exploitable, and it's a 0-day vuln. So it's a very important vulnerability that I'm sure everyone already knows about. So I won't go into too much depth at this stage. December 10th was when it was originally publicly disclosed. If the two things that it was really important to do is really just to identify where in your environment you use Log4j. It might not be immediately apparent where you use Log4j, so it's important, and we'll go through in more depth how that can be done. But the core advice here is where you can upgrade to version 2.17.0, and that includes all three of the vulnerabilities we just mentioned. Where you can't upgrade, there are other mitigations that can provide you partial or complete at the moment, what we believe is complete remediation for that. There's a full remediation cheat sheet that I wrote with one of the folks, Kirill, in our security research group. So feel free to check that out, and we'll talk through that and actually show you a couple of the remediations in this session as well. So back over to you, Micah.
Yeah, great. So Log4j, very popular Apache logging framework. And if you're like me, even as an experienced developer, it took me a little bit of time to kind of unravel what is Log4j versus SLF4j versus logback. How do they all hang together? And also, if you're like me, eventually you just kind of dropped it in and forgot about it. It just, logging worked. When I changed the logging level, it worked, and that's really all I cared about, and kind of haven't thought much about logging for a while. Log4Shell, however, as Simon mentioned, became kind of splashed onto the scene December 10th, and some of our team jumped right on it. We had a first blog post out right on December 10th, and it's evolved. If you've been paying attention at all, it's evolved over the course of nearly 2 weeks, where there have been now 3 separate remediation releases. And this is the double-edged sword of open source. On the one hand, you might be left with, wow, are we past this? Are we going to keep getting these updates? Probably yes, we'll keep getting updates. But on the other hand, we've been very rapid to respond, and as each new thing has come up, very quickly it's been patched. What you see at the bottom here is the original vulnerability that was disclosed, but there have been a few more after that, so make sure that you do upgrade to 2.17. That's kind of the bottom line, the best way to mitigate. As Simon said, there are some other remediation steps you can take. Maybe you're in a situation where you can't just go and upgrade, or you can't restart your servers on a dime, but there are some other remediation steps you can take. But the best approach is to upgrade to 2.17 for now. Looking at the anatomy of Log4j, what presentation wouldn't be complete without a poorly drawn diagram? This is the one that I've put together. Gives you an insight into my drawing skills. But if you have your app here, the big box, the nature of this Log4Shell vulnerability is that some time ago, and we're going to look at some of the history of this, the ability to drop interpolated strings into a message was added to Log4j, and there may have been a valid use case at the time. But what was discovered is that through the magic of Jindy, you can look up an endpoint. And so this humble looking string here with the $ and the curly braces triggers a pile of network interactions. And through this little string, it kicks off this network call through Jindy, and an LDAP request is made. So that LDAP request is triggered here. And then there may be this endpoint that's servicing this request, and it returns a carefully constructed response. Now, one thing you may or may not know about LDAP is, in addition to textual information for organizations and individuals, you can also have things like machine information. And in the case of Java, you can have some specially constructed LDAP responses that trigger an additional request for a remote Java object. So through the stack where you have Jindy making a request for a remote Java object and then deserializing it, you end up with Log4Shell. So when this specially formed LDAP response is returned, it includes an external reference. And when that HTTP request is made, what's returned is a byte array, which represents a Java class, a serialized Java class. And importantly, this serialized Java class doesn't have to be on the class path of the application. That's an important distinction that is not clear for everybody. So then that class is deserialized, and even though it's not on the class path, it's happily executed, and then some mayhem can ensue. So to take a step back and just kind of look at the history and how we got here, if we go back to the ancient times of 2013, we can see when this request was made to add Jindy lookup support to Log4j. And a use case was explained and a process was gone through. A patch was created to add Jindy lookups. And one thing I want to say here, just to take a step back and to put some context around it, I don't think anything wrong was done here. This is part of the open source process. Somebody said, "Hey, I have this great idea. Let's add Jindy lookup support to Log4j. Here's my use case." Some volunteers doing yeoman's work on an open source project said, "Well, this looks okay. Let's integrate it." And as evidenced by the fact that this has been sitting here kind of dormant since 2013, sometimes we have unexpected side effects. This is, kind of the nature of open source projects. So that's 2013. Interestingly, in 2016, there was a talk at Black Hat USA. All of this, will make sure that we have the links to these resources. They're publicly available. And this talk had 2 of the 3 components of what we now call Log4Shell. It didn't specifically call out Log4j, but it did call out the other 2 components using Jindy injection with LDAP entry poisoning to result in remote code execution. So this has been sitting here for a while, and I find it valuable to understand the history and how we got here. I was, maybe like you were, kind of taken aback to think that, how could you get to a remote code execution vulnerability, and how could you have this pile of network calls related to logging? It seems like it would be such a kind of a humble thing. Logging just, prevents us all from having to use system out print line and gives us kind of a more sophisticated way to log. But that's how we got here. So from here, I'm going to turn it back over to Simon, and we're going to get into some exploits and demo, and look at some remediations as well. You want to share your screen, Simon?
Absolutely, yeah. Thank you for the deep dive there on the issues. And I'm going to share my screen and show you a couple of things. So first of all, we're gonna really look at an application here, which is this Acme Corp application. This is a Log4Shell POC exploit, which is available on GitHub if you wanted to try this out yourself as well. Feel free to have a play, and we can share that. We can share the links in chat in a bit. Yeah, first of all, I'm going to show you how you can attack this from the outside. I'll show you a little bit about the types of the source code underneath and how this is logging, what it's logging, and then I'll show you the attack vector that we've kind of put together for it. So first of all, this is a very plain and straightforward application, which is running on a Tomcat server on my laptop. I can pass in a username password. So in here, I'm going to pass in admin as my username and password. And here, as you can see, this is obviously a very, very high sensitive information style website, because it's clearly putting password in the clear there. So I'm going to send that, and you'll see that it's welcoming me back, admin. Obviously a very high feature rich website here. That's all there pretty much is. One important thing to mention is if I was to do a typo here and I was to type admin and password, and I tried to log in, it says the password I entered was invalid. We will log your information. This is quite common. Logging across Java frameworks in your application, when error cases happen, when exception cases happen, or sometimes when it's just a regular transaction, it's common to log things so that you, from your auditable point of view, understand the different flows, how individuals are using your site, and so forth. But in this case, this is an error case, and we log the fact that a user or a username was incorrect. So let me jump back over to the code. Now, in the code, you can see here, this is a very basic application. This is just a POC application. But in our servlet, what we do is we check to see if the username and password is correct. If it is correct, it just sends a response back to say, welcome back, admin. If it is incorrect, you can see here that we're using Log4J here, and we just perform an error log of this message, in this case, just the username. You'll see in my log here, we're just logging admin. So this is my Log4J entry here. Now, as Micah mentioned, what we want to be able to do is perform an exploit where we as the attacker provide user input into this log, this logging of the username, whereby this will provide an LDAP request out to my evil LDAP server. And this is quite common for the attack is quite common to do this in perhaps a login screen, because it's a form that you can input data and have the potential for that data to be logged. So in this case, what we're going to try and do is use this login text box here, and this is where we're going to try and attack it. This is where we're going to put our malicious string. So over to a terminal, I want to show you some other pieces of malicious code that I'm going to be setting up. Let me cat the poc.py. Now, this is a piece of Python here that's going to ask me a few questions, such as some IP addresses of where certain things are going to exist, which I'll cover in just a second. But the important thing that this does is it creates a Java class, and it creates a Java class which, when initialized, will create a socket and connect that socket over to a specific host and port. And this is something which I, as part of this Python script configuration, will pass it a host name and a port name. It's going to be the host name and a port name of this EC2 instance, which I am currently on. So this is running in an EC2 instance. Now, what's this class going to do when it runs? Well, it's going to go through a loop, and it's going to continually read and write from this loop, and essentially act as a mechanism of taking commands, running commands, and sending commands back to my connected service. This is effectively going to be part of a remote proxy that we're going to set up. Okay, so after this class is added into this variable here, what we're going to do is we're going to create a file on my file system here in this EC2 instance. We're going to compile it over here, and we are going to make this available via an HTTP server, as Micah mentioned. This is the process that we're going to execute, which is going to create my LDAP server, and it is going to be sending back requests, or it's going to be sending back strings to say to my client, this is the string you need to look up this reference class from. So let's head out of here and let's actually run this. So POC, where are we? I need to run Python POC. There we go. So I need to pass in a few things. First of all, let me just grab some data. Okay, so the first thing I need to do is provide effectively the IP or location for these environments. So this is this EC2 instance. This is only accepting requests from my laptop right now, so it's somewhat safe. I'm going to enter a listener for my LDAP ref server. So this is going to be my HTTP server that Micah mentioned that is going to be serving the malicious class file. So there's that. And also, I want to be able to create a reverse proxy. I'm going to create a shell, the actual, the Log4j shell, or rather the Log4Shell reverse proxy there. So I'm going to open that on port 9001. This is effectively where I'm going to be setting up Netcat to be able to connect to my laptop. So I run that. This has now stood up an LDAP server, and this is the string that is required to connect to that LDAP server to grab that class. So a couple of other things that I want to stand up. One is the Netcat listener. This is the Netcat listener that my laptop is going to go and connect to this machine. And the other thing that I need to set up is an HTTP server. This HTTP server is going to serve content from my location, and you'll also see the exploit.java. When poc.py ran, the exploit Java was created passing in the host name and port of this EC2 instance, and exploit.class is was compiled with the Java version just here. So let's stand up a HTTP server. And there we go. So we have our HTTP server that is serving exploit.class. We have a netcat listener, which when exploit.class gets downloaded to my laptop and my laptop executes it, it's connecting to this listener, and we have a reverse proxy. And we also have our LDAP server listening down here. And this LDAP server is going to be passing back the reference to our HTTP server. This over here is the string I need to send as the string that gets logged. So as soon as this is a username that doesn't exist, this username gets logged, Log4j will go ahead and say, I'm going to evaluate this because this looks like a variable. It reaches out to the LDAP server on my EC2 instance, pulls down the reference to my exploit class, which lives on that EC2 instance again, but on the HTTP server. It grabs that, it then executes it on my laptop. That then goes out over to the HTTP server, grabs the exploit class, it executes the exploit class locally. That then reaches out to netcat, which also exists on that, and then we have our reverse proxy. So I explained that. Let's hope this works now. I click that, it just spins around. Okay, so let me go ahead and come back here and see what we can see. Well, we have on our LDAP server, you can see we've had a connection, and this connection sends back an LDAP reference. And it says, go to this exploit class and execute this exploit class. Wonderful. Okay, so let's add a couple of, whoops, pardon me. Let me just unfull screen that. There we go. Let's add a couple of carriage returns there so we can see if any others come in. We have on our HTTP server, we can see a request that's come in. And we have a GET request for this exploit.class. So it's been pulled down. It's been executed, as you can see. And we have a connection from our NCAT listener. So if I was to do things here now, like let's say, who am I? I am Simon Maple running on my laptop. I can say PS minus EF. And those are all the processes. I can say ls. This is the place that I'm running Apache Tomcat from on my environment. I can say let's cat my /etc password. There's my sensitive information. So I'm going to cancel that. Let's cancel each of these as well. Okay, we'll leave the LDAP reference. We'll leave the LDAP server running. So this is the exploit that we've just made. Now, there are a number of ways in which this originally was said this kind of thing could be remediated. We're going to go into a couple of them now. First of all, what I want to do is show you this exploit window. Remediation cheat sheet. This provides a number of different ways in which each of these can be ways of which you can actually try and remediate. Number one is a very, very important one, and one that you need to start off with and think about very, very carefully. It's identifying where all your paths are that can find Log4j instances, because Log4j is not just something that you might use for your application, and as a result, you know, it's not black and white as to whether you'll know you're using it or not. Because so many other libraries use it, you could be using it as part of your frameworks, as part of your other libraries, and it's extremely hard as a result to recognize whether you do that or not. There are some ways in which you can do this via something like Maven dependency tree and things like that, although for some shaded jars and things like that, that won't work. There are other ways in which tooling can help you, such as you can use, and by the way, everything that we show you today around Snyk is fully available on the Snyk free plan. And Snyk actually doubled its the number of projects that you can test just yesterday, in fact, to help the community based to test and identify and fix these issues. So you can go to snyk.io and try everything that we're going to show you today. The first one is being able to test and identify where your projects use this. The second one is being able to test unmanaged. Jars that come in outside of your package management environment, your build process. And thirdly, identifying shaded jars, fat jars, jars that have been forked and exist on Maven Central, for example, but maybe something that you wouldn't pick up naturally and straight away. So these are different ways in which you can identify where Log4j exists on your environment. Let's go ahead and, in fact, let me just cancel this request as well. Let's go ahead and identify how we can do, how we can perform an import and grab that today. So I've already logged into Snyk. You can do this very simply going to snyk.io and creating a free account. Then what I will do is I'll go ahead and add a project. In this case, I'm going to grab a GitHub project, and in this GitHub project, I'm going to open. I believe it's called. Is it called POC Log4J? There it is. Log4J Shell POC. Okay, so let's add this selected repository. And what Snyk is going to do now is it's going to identify the different artifacts in that project, in that repository, and identify how it can scan them. So if it finds a POM XML, for example, it's going to perform an SCA scan on it. If it finds a Java artifact, it's going to perform a static analysis, a SAST-like scan. Again, similarly with IAC, Terraform scripts, Kubernetes files, container files as well, Docker files and things like that. But this is importing now, and you can see it's found, for example, some local content, some Java files already. But what I want to do is take a look at the if I was to open this up, I want to find the POM XML. So you can see this is completed, tested just a few seconds ago. So this is accurate compared to, as of that scan. I open that and you'll see a number of things that exist in here. In fact, let me jump over to the dependencies straight away. This is the dependency list. You can also see the dependency graph. Now, where Log4j exists can very much determine how you go about fixing this. In this case, Log4j exists as a direct dependency rather than as a transitive. So a direct dependency being directly from my application, a transitive maybe being several levels deep somewhere in my dependency graph. So for a transitive dependency, I need to upgrade this from 2.14.1 up to the necessary version, which in this case is going to be a 2.17.0. So I could go ahead and take a look at my issues, see more information here, the priority score, a whole bunch of different things, create JIRA issues, et cetera, But what I want to do is I want to go ahead and let's fix this issue here. So this is in the Log4j core. In fact, I'm going to upgrade all my Log4j core issues. And this is effectively going to upgrade everything up to version 2.17.0. So it's gone ahead, well, Snyk has automatically gone ahead and sent that to my repository. And it can do that because I imported from my repository. And you can see it's bumped up that version to 2.17.0. The issue, the security issue here is in my Log4j core. There are, of course, many other ways in which I might want to do that. So, for example, maybe I want to do that from my IDE. So in my IDE, I can go ahead and go to Snyk. Again, this is entirely free. I can click on the play button there, and it's going to do some scanning across my code, or as well as open source code. And you can see in my POM XML, it's found several vulnerabilities, and these remote code execution vulnerabilities, it provides me with my fixed version. So in this case, 2.15, 2.16, and 2.17. So what I might want to do is go over to my POM XML and upgrade this directly to a 2.17.0. We'll do that in just a second. But what I also want to show you is a scan. Let's go here. A scan of, if I was to go into vulnerable application, a Snyk scan running at the command line. So I can just go ahead and type Snyk test in my local environment where you see my POM XML is. So I can run Snyk test. And what this is going to do is going to run the same test, but in my command line interface. So it provides me with the same vulnerabilities as well as information about critical ones within Log4j and resources that I can fix these in. This will also provide me with versions at which I need to fix this, so 2.17.0. So let's go ahead and perform this fix. So in this case, I'm going to upgrade this from 2.14.1 to 2.17.0. And in fact, what I'll go ahead and do is I'll keep my API and my core in sync with this. So I save that. I go ahead to my terminal and I'll run Maven package to rebuild that application. And in fact, if I was to go back here and run this, you'll see that Snyk is calling this POM.xml obsolete, this scan. So I'm going to rerun that. And hopefully that will just say no vulnerabilities that exist in this scan, no issues found. Perfect. So we now have the 2.17.0 in my application. So I'll go and let's refresh that server. And while that's happening, I'll just reset up my environments over here. So let's pull up the HTTP server. Let's pull up the NCAT listener. And let's pull up. Actually, we can leave the LDAP server there. You can see the gap there between the last call and hopefully nothing else here because this won't be called. I go back. I'm not sure if I still have that in my. No, I have 2.17.0 in my cache. So let's go back here and grab this string, the string that it wants. Copy that, add that into the username, anything into the password. I click login, and this time, rather than hang, it takes me straight to that password you entered was invalid screen. And if I come back to my EC2 instance, there is no LDAP request. There is no netcat connection. There is no request on my HTTP server. So that exploit couldn't happen because we upgraded to 2.17.0. Interestingly, I think from 2.16.0, the JNDI service or the JNDI capability, the JNDI lookup capability was removed from that Log4j instant version, whereas 2.15, I believe it's still there, but they try to mitigate much more surgically. But unfortunately, one of the problems with that with these 0 days, sometimes we tried so quickly to fix those, other issues can be exist. Okay, so yeah, good point. Actually, putting in here, Log4j has two jars, core and API. Sometimes you actually don't use core. Sometimes you only use API, I believe, right? So what a good idea is to know what you're using and actually to only use what you need. That's a really good point there as well. Let's try another fix. And in fact, this is, if I go back to my cheat sheet, you'll see that there are a couple of other things. We did the upgrade here to 2.17.0, and we also did the pull request as well to show that happening. What we want to do now is perhaps something that if we didn't have access to the pipeline, didn't have access to the source, maybe we don't own the source. Maybe it's someone else's. Maybe it's someone else's application, like maybe GitHub Enterprise, for example, whereby we own a GitHub Enterprise instance. We want to fix it, but we can't do an upgrade, right? We need to be able to fix it more on our local environments. One possible way of doing that is to remove the JNDI class. Now there are other classes as well that you could consider, including JMS Appender, which I believe was mentioned in the chat. But yeah, this is a good way of being able to remove it from a runtime. So let's take a look at this. Now, if I go back to my environment here, in fact, what I'm going to do is I'm just going to very briefly reset my environment. So let's go over to a vulnerable version, so 2.14.1. Let's quickly Maven package that up again. Let's put that back into our Tomcat server. And we're going to very quickly go back to this environment. Go back here, just to double check that this is once again vulnerable. So there's my vulnerable string. So we're back on 1.14.1. Oh, sorry, 2.14.1. I run that, and hopefully, if I come back here, yep, there's our exploit class that has been downloaded. If I type ls here, we have that remote connection again. So let's refresh that again. So we now know this application is vulnerable. So let's now try and remove that vulnerability. Perfect. Okay. Now, what we're going to do is we're going to go over to this environment here. This is, if I do a pwd, you can see that we're in our Maven cache, right? This is where our Log4j core lives that we're pulling into our build. You see we're at 2.14.1. If I was to, let's run jar. If I'm going to jar minus tvf, so looking inside this Log4j core jar file, if I grep JNDI lookup, you'll see the JNDI lookup class exists there. I'm going to go back to my cheat sheet if I can. There it is. Let's grab this command. And what this command is going to do is it's going to, what happened there? Okay, let's not do that. Let's go to, actually, I might even have it in my history. There we go. What this command is going to do is it's going to, let's do a -Q there as well, just to quieten down this command. It's going to delete the JNDI lookup from the Log4j core. So if I do that, it removes the class. Let me quickly jar to make sure it's not there. So the JNDI class no longer lives in that core library. Go back over to my runtime. Let's re-maven package. So let's package up that new version of my core, my API core, and let's deploy it. Now we're running the, I'll redeploy that one anyway. Now we're using the 1.14.2 version less the JNDI lookup file. If I come back over to my EC2 instance, let's just double check everything is running here. We have HTTP port, we have NCAT listener, and we have our LDAP server running there as well. Okay, so let's go back to our, have I still got this in? No, I haven't. Let's go back and add that back into my clipboard, that file. Here it is, that string. Now let's try and see if this will work on that. So here is my malicious string, any password. I hit login. This time it doesn't work. I wonder if we get an exception. No, we don't get an exception. Sometimes you might get an exception, or sometimes you might get weird behavior because you're essentially just ripping classes out of the runtime, right? So this is a little bit less a polite way to fix a live runtime, but nevertheless, it in this instance works, and there are other ways of doing that. One other thing while I'm at the command line that I wanted to show you, I probably should have shown you this a little bit earlier, but I wanted to make sure I show you this. At the command line, there are some jars that you equally want to look at. Some of them are, for example, shaded. Now, a shaded jar, it could be a jar that perhaps has been, maybe forked or included in other things. Maybe it's a part of a fat jar, or maybe just renamed or something like that. What Snyk has now got in the Snyk CLI. So if you're using the Snyk CLI already, make sure you update to the latest version. You can do something called Snyk Log4Shell, and what this will do is it will look across your directory structure and identify where your shaded or fat jars are, look inside them and see if it can identify those against Maven Central. So you can see here, we have a couple that exist in my vulnerable application. These are managed jars. And these were the managed jars that it found from that my POM XML was pulling together. But these ones are not managed. This is a fat jar that contains my Log4j core. This is a shaded jar. This is forked and would exist on Maven Central. This is a shaded jar. In fact, this is just an unmanaged jar. This one. This is the actual Log4j environment, Log4j library, the core library, but it didn't find it from the POM XML. It found it because it exists, and it matched that to the instance on Maven Central. So that's another important way of doing it. Okay, let me go back to the cheat sheet. There's a few other things that I just want to kind of clarify before I pass back. Actually, we're running out of time a little bit, so I'll speed up very quickly here. Disable lookups via properties. This isn't something that you want to rely upon. This was something that we did previously, but it is no longer enough. This is something which you shouldn't do. The second vulnerability, the second remote code execution vulnerability, in fact. I believe the properties, etc., it gets around that. Upgrading your JDK, again, this was thought as a remediation previously, but it is no longer safe to rely upon an upgrade. It won't catch all environments. Blocking malicious requests in your WAF. This is something which a lot of people rely upon way too much. Attackers, when they try and make requests and they get caught by your web application firewall, those rules will exist almost temporarily well, in a sense that attackers, when they realize their requests are getting caught, they'll slightly modify their attack string and get around those rules. These rules tend to last a number of minutes or a number of hours before an attacker will find a better way of being able to get around that. And then finally, egress is just about policing the traffic that goes from your environment out. But I won't talk about that too much because I want Eric to be able to chat about that in some of his container work. Okay, with that, I shall pass back. Sorry, that took a little bit longer than I expected.
Well, good, Simon. Next up, we have Eric, who's going to dive into container as relates to Log4Shell.
Thanks, Micah. And thanks, Simon. That was great. So I'm going to be quick here because we have limited time. Just quickly, what I'm going to show you is a demonstration of a similar hack against our standard Snyk demonstration app that we have all sorts of vulnerabilities in. We call it Goof, Java Goof in this case. And I have a Kubernetes cluster stood up running in EKS and running in the default namespace. I have started the Goof application up. It's running in its own pod, fronted with a service and the load balancer and all that. And what you'll see me do is send our favorite string, our version of that favorite string, down into that pod, and we'll see what happens. So let me jump over to my demonstration. On the left is simply a shell. It's tailing a log. You can't see it right now because I cleared the screen. And on the right is our to-do app. I've logged into it, and we have some sample to-do items in here. And just to show you, if I search my to-do items for you're seeing a log line with it. We're using Log4J, and it's obviously the vulnerable version. And it says, hey, somebody search for I can put in Eric, and it searched for Eric, even though nothing was found. But if I come in here and we put in JNDI :LDAP : / in my case, it's LDAP.darkweb on port 80 /ping vandalize. As soon as I hit that, you see the log line roll. So there's the string that went out. And all of a sudden, the header of all the JSPFs on my page have this nice vandalized message put into it. And of course, that's innocuous. I could have done literally anything I wanted in a shell script because that was my payload. I could have installed things. I could have done all sorts of stuff. So what can we do to mitigate this? So what happened was I have another namespace in my Kubernetes cluster named dark web, where I've got the vulnerable LDAP / web server. It's kind of a 2-in-1 that we've written that served it up. And we hit LDAP.darkweb, and then it returned a string, which caused us to then look at evil.darkweb. And all of the stuff you saw Simon do just kind of happened for us. Now, the fact that it's in Kubernetes in a dark web namespace is irrelevant. That was easy for me to set up and easy for me to use DNS to look up. This could also be anywhere on the internet that I had resolvability and connectability, which goes to what Simon just mentioned about egress control. So in most environments, we're going to have some firewalls. You're going to have perimeter firewalls, and you may be blocking egress out of your network to the internet, which is good. And you should do that. And you should have perimeter firewalls. However, anyone who's been a developer for any amount of time knows that as you start moving things around and changing your application around, coordinating what you're doing to your application with your firewall team via ServiceNow tickets or whatever mechanism you have to do it, can become cumbersome and errors can happen. Secondarily, just because this thing could be on the internet doesn't mean it is. It's very possible that my laptop got malware on it when I was at Starbucks, and I came into the VPN or into my corporate network, and now I log into a Bastion host, and all of a sudden the malware says, hey, calls home, says, hey, look what I see, and they put up an LDAP server somewhere else in your network, or on a reverse tunnel back to my laptop. All sorts of things like that can happen. What we can do as a kind of a belt and suspenders in Kubernetes is use network policies. If you're not familiar with them, they are basically a way of firewalling, if you will, or controlling network traffic between pods, both ingress and egress. Let me show you what they look like. And a lot of developers get antsy about network policy. It's not difficult. It's not really hard. It's pretty easy to understand. It's a set of rules. Pods can or cannot talk to each other based on these rules. And this is a simple one. This is a network policy that says it's named not deny egress. It has no namespace specifier. I'm going to deploy it to my default namespace. It is saying apply to all pods. That empty brace with no definition in there says this applies to all pods that I deploy this to. And the rules are this is an egress type with the only egress traffic allowed being port 53, which is DNS on both UDP and TCP. That means nothing else should be able to exit my pod. So let's go ahead and apply this. And I'm going to go back over here. I'm going to bounce my pod to get rid of that exploit that already has been applied. So I'm going to delete the goof, oops, delete pod goof. K is alias to kubectl because I'm too lazy to type. And while that is coming up, just show you what we're going to be having basically is you see a padlock here, right? Nothing is going to be able to come out of that pod. And this would apply to all pods in default in this case. In whatever namespace I apply this to, egress is not allowed. Now, obviously, if your application needs to connect to end-tier type things or backends or databases, you would define, say, hey, I am allowed to connect to a selector that matches where you can connect to. You can also set up and should set up ingress for the things that you want connecting to you. So you can kind of have the both direction definitions. If that is done, let's start tailing a log on it. Come over here, go back to the top, and sign back into my app. And we'll do a test just to make sure the app's working. Yes, and there's the log down there that says search for the, and we'll paste back in my string, and it's going to sit here and spin. Now, this isn't perfect. This is not a silver bullet, but it does help you to give you a little bit of breathing room while you are figuring out where to do all the things Simon just talked about, patching your applications. Technically, I am taking up a thread in the Tomcat server in this case where it's sitting there, it's timing out, trying to connect to ldap.darkweb or ldap.Eric Smalling's hacker site or whatever. So it's not the only thing you should do, but it's just another area of mitigation you can do. Now, another thing, wow, that's spinning away. So that's just, it could be anywhere, right? Another thing is security contexts. So in your pod definitions, there are things called security contexts. And this is an API. Let me show you my deployment YAML. Java Goof YAML. So this is what we deployed. And you can see, this is, if you know anything about Kubernetes, this is the most basic you can do. It doesn't do anything other than say, here's the image, I want one of them, and here's the name. And with a little variable substitution magic, that deploys just fine. Here's a version of that with a security context added. In this case, it is saying, do not let this container run as root. Now, if I were to go through and demonstrate more of this, I could show you that I'm root in that container. And even though I'm contained, that is an elevated privilege. That's UID 0 inside the container's name, file system space. I could edit things. So if I were to change, and in this case, Tomcat's case, they have a nobody user that I could change to. And if I were to do that, in this case, I'm actually explicitly saying run as user 65534, which is that user. You can inspect the image to find that out. That user is able to run the app and execute and do all the things Tomcat needs, but it can't edit the web apps. It can't do a lot of things. It's not a silver bullet, but it's a good practice. Additionally, there's another security context that allows you to basically say this entire container, make the base file system read-only, which is just another level of my thing timed out in the back end there. Another level of making your containers immutable makes them even harder for hackers to do things with them. And again, these aren't areas that would disable the Log4j issue, but they make it less useful for setting up a beachhead to move around. Finally, scanning your images. Now, I've already done this for sake of time, but at the bottom, and hopefully you can see that, this command, Snyk container test, or if you're a Docker user, Docker scan uses the same scanner in the background through our partnership with them. I'm testing, this is a copy of the image I have locally, and the key piece here is this -- app vulns. That feature goes in beyond the normal container scan, which looks at your app repos, your yum repos, all the things that normally make up that you would have in Docker files, but it actually looks at the contents of the files in there. And we have updated, and we continue to update this with new ways to find these jars. And it's looking for, and you can see at the bottom of the output that I already ran, it's got a nice big purple output saying, hey, Log4j is in this app. That is the WAR file, the exploited WAR file that I have put into the image we just ran. In my own build, it's not part of a base image. It's actually something I added myself, and we're still able to detect it. So you should scan your containers with that tool to make sure you know that it's in there. And with that, I think I'm out of time. So I'm going to bounce right back to Micah.
Excellent. Yeah, really, really great stuff. And as you can see, we could go on even further about this because there's so much meat to it. What I'm going to share very briefly is a quick overview of what's actually happening when Log4Shell is being exploited, when Log4j is being exploited with this Log4Shell, and then we'll leave time for questions. Now, if this is too quick, if I'm going through this too quick, this is what I'm showing here is publicly available. As Eric said, this is our Java goof app, and we've just recently added a whole Log4Shell section that has instructions on how you can run it and how you can test it locally. So it's publicly available. But what I specifically set up here is kind of all the components that we need for Log4Shell. And I do want to point out, I'm running everything, both the server and the client here, using Java 11, but I've purposely passed in some parameters here that allow me to still do the exploit, even with an updated JVM. So first of all, don't do this at home unless you know what you're doing. And second of all, ordinarily, this wouldn't be possible with Java 11, but it's a lot easier to step through the inner workings of the code with a more modern JDK. So first thing I want to point out is server. This server is running a very lean LDAP and HTTP server. They're very purpose-driven, and they're just going to sit there in the background listening for connections like Simon and Eric have demonstrated in other contexts with different repos so far. But we have an LDAP server listening on its port and an HTTP server listening on its port. The next thing I'm going to do is kick off main. And if we look at main, it's doing something very simple here. First of all, it's showing you the JVM that you're using, just some stats about it. Then it's doing a simple log just to show that Log4j is working and it can log stuff. Part of this, as for the sake of demos, what we're going to see is that the punchline here is that a file is going to be written to /tmp pwned, PWNED. That's going to be the end result of this exploit. So what main is doing here is checking that temp file is there, and it's saying false. It shouldn't yet exist at this point. Then we're going to log out an exploit string. We're going to give it a beat to actually write the file, and then we're going to check that it does now exist. So this is kind of a fully enclosed demo. But what I want to demonstrate here is actually what's happening inside of all of the Log4j code. So I've set up some strategic breakpoints, which we're going to look at now. So this is that JNDI lookup class that Simon deleted earlier. And we can see that it's caught this Jindy string, and it's now going to go and perform the lookup. It's going to take advantage of that mechanism. Now, the next breakpoint we have at this point, if I look over here in the server, I can see that the LDAP call has been made as a result of the JNDI mechanism. And what it's assembled here is, if we look at these attributes, and this may answer a question that I saw in the Q&A section before. The question was, well, why don't we just return the malicious class directly from LDAP? Why do we need this HTTP piece? The reason is that there's only so much that we can return as a valid LDAP result. And you can see that in here, in the attributes of this LDAP result, we have these 4 specific attributes: object class, Java code base, Java factory, and class name. And this is what triggers the mechanism in JNDI to then perform the remote lookup and retrieve the malicious class. So we can see that we have this Java code base that's referencing our HTTP, and then it's got this thing called a Java factory. And what it's going to do is it's going to get this, when it's going to make this remote call to HTTP, it's going to get back this byte array, and it knows that it's of a particular type, this factory type, and then it's going to execute a specific method on that class that's coming back. So let's continue on here. And now we're at our directory manager. So now at this point, it's got the LDAP information and it's about to get the object instance. So it hasn't yet called HTTP, but it's just about to. And if we look back again, we see that we have these attributes that it's using to make that HTTP call. Okay, so now at this point, it's just about to take this reference that it has. Those are the attributes from the LDAP call, and get object factory from reference is the thing that's actually going to take those values and now make the HTTP call. Looking in the console, I can see that the HTTP call has been made and that we've returned this byte array that represents the this payload. And if we look here, we can see that this factory reference is now referencing this evil class. And one thing I want to point out here, I know I'm moving around pretty quickly here, so you know, feel free to examine this on your own. But I do want to point out that in this Log4Shell client, there is no evil class in scope or in the class path or anything else. That evil class exists in the Log4Shell server class, which is kind of walled off. But through the magic of deserialization, we now have access to it. And in fact, the part of the way this factory mechanism works is it's going to go and call this get object instance. And if I jump into that, now we're inside the evil class. IntelliJ is able to show it to me because it's in scope of another element of this project. And now I can see that what is about to be executed is writing to this temp pwned file. And it could be doing anything here. It could be exfiltrating my password file. It could be, you know, listening for incoming connections. It could be installing malware. In this particular case, we're going to let it finish. And we see now that you've been pwned. So now that temp pwned file does in fact exist. Where am I? Here I am. Oh, right. I gotta stop sharing my screen now. Okay. So that was kind of a whirlwind tour. We meant to give more time for Q&A, but we still have a few minutes. So let's jump right into Q&A and go from there. And who wants to take some questions? We have a couple of open questions.
Yeah, so I think me and Eric just realised there were a ton of questions in the Q&A, so we're trying to go through them as quick as possible. I can
great.
do some live here as well. To be clear, in fact, Mike, why don't I ask this one to you? To be clear, does automated pull requests provide indirect dependency upgrade as well? Not necessarily for Log4j, but in general for Java and JavaScript indirect dependencies.
That's a good question, and I do believe it does, but I will have to verify that.
Yeah, it does. It's so the fix is always to provide an upgrade to a direct dependency. So if you've got a transitive 3 levels deep, for example, and you can't just upgrade the transitive dependency itself. You need to upgrade the fix to a certain version, and that then pulls in the child dependencies, the transitives at higher versions. So what Snyk does is it identifies what the minimum jump your direct needs to pull in your transitive at the fixed version. So the advice from Snyk, or the pull request from Snyk, always upgrade your direct dependencies, but depending on where your vulnerability is, it has different impacts.
Excellent. And I see you've answered a slew of them, so thanks for that. We had a lot of good questions there. Any other open questions we want to take in the last minute or so? I'm just going through myself right now. Here's one from David at the bottom. Why is log4j 2.format message no lookups equal true no longer considered an acceptable temporary remediation measure? At least part of the answer there is that while you may address the RCE issue, you may not address the denial of service issue that exists with still with the older versions. So, the TLDR and all of this is you want to get to the point where you can upgrade to 2.17.0 as of today. And we understand that that's not always possible or in a timely fashion. So some of these other remediations will get you most of the way there and might address some of the scariest issues, but you may still have additional issues floating around if you don't do that version upgrade long term. All right, we are at time, so I want to thank everybody for joining us today. We'll make sure that we send out the link to the video and reference links to all of the repos and stuff that we covered today. And I want to thank Simon and Eric and Sarah and Lauren for all the time that was given here today. And have a good rest of your day, everybody.